The nano world. What is nano? The term nano refers to a unit meaning 1 billion or 10 raised to negative 9. For example, a nanometer is 1 billionth of a meter, hence nano express a very tiny amount of size. Compared for the one strand of the hair, nano is between 50 to 100 times small, 50 to 100,000 times smaller than strand of the hair. Technology. Nanoscience. This refers to the study of exceptional small things that can be used across all all the other fields of science such as biology, chemistry, physics, material science, and engineering. Nanoscience study a structure and a material can ultra small scales and unique and interesting properties these material demonstrate. In acro- is across disciplinary means scientists from from a range of fields including chemistry, physics, biology, medicine, computing, material science, and engineering are studying it and using it to a better understanding of our world. So the next is the nanotechnology. Nanotechnology, this deals with science, technology, and engineering accompanied at the nanoscales, which is about 1 to 100 nanometers. In nanotechnology, application of nanoscience leading to the use of new nanomaterials and nano-sized components in useful products, which will provide us with ability to design customized materials and products with new enhanced property, with new nanoelectronics components, with new types of smart medicines and sensors, and even interface between electronics and biological science. Those newborn scientific discipline and situated of the enterprise between physics, chemistry, micro, microelectronic, biochemistry, and biotechnology, which control of those discipline therefore requires an academic and multidisciplinary scientific education. The nanotechnology production. One of the examples of the nanotechnology production that has used during the pre-modern era has Maldives stained glass window or ginatawag nato siyang nanobayonet. Nanotechnology production. Materials in nanosize how uncommon physical and chemical properties caused by several factors include the increase in its particular surface area. Based on the latest research, nanotechnology helps enhance the quality of the following biomaterials, ceramics, metals, polymers. Biomaterials are used in healthcare such as imaging tools as bioengineering to detect disease, monitoring, prevention, treatment, or several diseases for instance cancer, cardiovascular disorder, diabetes, inflammatory condition, and some infection disease. And next is ceramic. An example of the nano-ceramic paint coating. It is used as a car paint and coating to provide strong protection and shield that keep the paint of the car to look shiny and brand new.
metals. A good examples of this are tennis and badminton rackets. It increases the strength of the metal 200 times by rolling up the sheets of carbon atoms. The scientists have been working on other super strong version of carbon atoms called carbon nanotubes, which consist of sheets of carbon atoms rolled into tiny cylinders. The figure below shows single-walled carbon nanotubes and multi-walled carbon nanotubes. The arrangement of the structure of materials at the nanoscale can change its strength. For instance, a pencil contains a graphite which is made of carbon atoms that are arranged in sheets. This can easily slide around when writing because graphite sheets can easily rub off into paper. Another example, in diamonds, carbon atoms are tightly packed together, making it so hard that they can cut steel. Polymers. These have been used to enhance and computer strengthen chips, especially its design. A polymer is any of a class of natural or synthetic substances composed of very large molecules called macromolecules, which are multiples of simpler chemical unit called monomers. Polymers make up many of the materials in living organisms and are the basis of many materials and man-made materials. Commercial applications. Some of the commercial applications of nanomaterials are: first is sunscreen. These sunscreens provide protection from harmful UV rays of solar radiation. These have been possible through the use of nano-sized zinc oxide that reflects and absorbs UV rays and make it ultraviolet resistant. Number 2, self-cleaning windows. These self-cleaning windows break down the dirt and stain repellent fibers that can be washed away by rain. This has been possible through the use of nanomaterial of unique chemical properties.